Have you ever wondered what the most expensive material on Earth is? It's not gold nor diamonds, but a substance known as antimatter. Yes, you heard it right. Antimatter. This elusive material is not something you'll stumble upon during a Sunday afternoon stroll. It's incredibly rare, found in minute quantities in the universe and even scarcer here on Earth. Now you may be wondering, why is it so expensive? Well, the answer lies in its production. To create even a tiny amount of antimatter requires an astounding amount of energy, sophisticated technology, and yes, a hefty price tag. We're talking about a staggering $25 billion for just 1 gram. That's billion with a B, my friends. So what makes this material so special, and why on earth would we pay such an exorbitant price for it? Let's dive into the fascinating process of how this costly material is made. Opening. Antimatter isn't something you can just dig out of the ground like gold or diamonds. It's created in high-energy environments, like those found in particle accelerators. Now, you might be wondering, what exactly is a particle accelerator? Well, it's a type of scientific instrument that uses electromagnetic fields to propel charged particles to high speeds and to contain them in well-defined beams. In other words, it's a machine that smashes atoms together at nearly the speed of light. When these particles collide, they create an enormous amount of energy, and as we know from Einstein's famous equation, E is equal to mc squared, energy can be converted into mass. This is where the birth of antimatter takes place. But how does this happen exactly? When these high-energy particles collide, they can produce pairs of particles and their antiparticles. For example, a high-energy electron colliding with another electron can produce a pair of electrons and positrons, where the positron is the antimatter counterpart of the electron. Now you might be wondering, where on Earth are these incredible machines? The answer is CERN, the European Organization for Nuclear Research, home to the largest particle accelerator in the world, the Large Hadron Collider. It's here that scientists are creating tiny amounts of antimatter, pushing the boundaries of our understanding of the universe. But creating antimatter is no easy feat. It requires immense energy, advanced technology, and a deep understanding of the fundamental laws of physics. And even then, we can only create a minuscule amount. So, why go through all this trouble to create something so small and difficult to handle? Well, antimatter holds great promise for the future of energy production. Just 1 gram of antimatter could produce an explosion bigger than the atomic bomb dropped on Hiroshima. Capturing antimatter is no easy feat. It requires precision, patience, and a whole lot of technology. If you thought catching a butterfly was tricky, try capturing something you can't see, can't touch, and that will annihilate in a burst of energy if it comes into contact with anything, literally anything. Enter the heroes of our story, Penning-Malmberg traps. These devices are the unsung champions in the quest to capture and store antimatter. Picture a trap, not with bait and a sprung door, but with invisible walls made of magnetic and electric fields. These fields are meticulously designed to hold antimatter particles in place, suspended in a vacuum, without letting them touch any normal matter. The Penning-Malmberg trap uses a combination of static, electric, and magnetic fields. The electric field is used to confine the particles along the axis of the trap, while the magnetic field keeps them from straying sideways. It's a bit like trying to balance a marble on top of a needle. It requires a delicate touch and constant adjustments to keep everything in place. The technology and precision needed to maintain these fields are mind-boggling. We're talking about forces that need to be fine-tuned to the billionth of a second, and technologies that operate at temperatures colder than the depths of outer space. Even with all these precautions, antimatter can only be stored for a short period of time. The longest we've managed to hold on to antimatter is just over 16 minutes. That's less time than it takes for a kid to decide they no longer like the meal they begged for just moments ago and turn it into a spacecraft on their plate, complete with mashed potato aliens. But let's not forget, the process of capturing and storing antimatter is not just a scientific feat, it's also an engineering marvel. It requires the efforts of some of the brightest minds and the most advanced technologies we have. So you see, capturing antimatter isn't just about scooping up particles, it's about pushing the boundaries of what we know and what we can achieve. It's about exploring the very edge of scientific possibility. Now that we've captured our antimatter, why does it cost a fortune? The cost of antimatter is astronomical, and there are several reasons why. Firstly, let's talk about production. Producing antimatter is an energy-intensive process. It's not like mining gold or drilling for oil. To create antimatter, we need to accelerate particles to nearly the speed of light and then smash them together. This process requires vast amounts of energy. In fact, It's estimated that to produce just 1 gram of antimatter, we would need to use the total energy output of a nuclear power plant running continuously for several days. And remember, that's just for 1 gram. Secondly, there's the rarity factor. Antimatter is not naturally occurring on Earth. It's created in particle accelerators in minute quantities. To give you an idea of how rare it is, consider this. Since the mid-20th century, we've only been able to produce about 20 nanograms of antimatter. That's about as much as a single grain of sand. So just by sheer scarcity, antimatter is incredibly valuable. Then there's the challenge of containment. Antimatter can't be stored in a regular container. It annihilates when it comes into contact with normal matter, releasing enormous amounts of energy. This makes storing antimatter a technological challenge, and an expensive one at that. Special magnetic traps are needed to keep antimatter from touching anything else, and these don't come cheap. Finally, there's the research and development aspect. The science and technology behind antimatter are still being developed and refined. It's a cutting-edge field, requiring top-notch researchers and state-of-the-art facilities. All of this contributes to the overall cost. So there you have it. The most expensive material on Earth is not an element found in the Earth, but a product of our technological prowess and scientific curiosity. If you ever get your hands on a gram of antimatter, handle with care. It's worth more than its weight in gold. I hope you enjoyed today's video. And check out our channel for more quality content. Until next time.